So here we have the most important equation in all of finance. Present value equals future value divided by 1 plus r to the t power. Let's talk about what these different variables mean. Present value is PV. All that PV, or present value, means is happens before FV, which stands for future value. Both of these could be at any point on the timeline as long as PV is before FV. They could both be in the past, they could both be in the future. PV could be today, FV could be 30 years from now. All sorts of different combinations are possible as long as PV comes before FV. And then we have R. R is the required rate of return, and T is the number of periods. Now, let's say something about R and T here. They have to be on the same time scale. So if R is in per year, then T needs to be in here also. So we just need to make sure that those things match. Otherwise, we're good to go. Now, the first thing we're going to do is solve this for future value. But before I do that, let me explain why this is the most important equation in all of finance. It's because the price or value of anything is the sum of the present values of all of its future cash flows discounted at a rate appropriate to the risk of those cash flows. And so this formula we're looking at right here is the basis for pricing everything. It's the basis for pricing stocks. It's the basis for pricing bonds. You'll also see it in pricing derivatives, though they get more complicated. But it's everywhere we look when we do pricing. In fact, you can see that real estate gets priced this way, commercial real estate, where the future values would be the rents that the building will receive over time. So now we're back to trying to solve for future value. What should we do? Well, we want to get FV by itself, so we need to multiply both sides by 1 plus r to the t. Okay, what we can do is cancel these because anything divided by itself is 1, and 1 times future value is just future value. And so we're left with future value being equal to present value times 1 plus r to the t power. We're going to start off with the equation that we found where we solved for future value, and we're going to use it to solve for r. And so we notice that r is over here on the right-hand side, and so our goal, of course, is to get it by itself. We're going to do the order of operations backward, which means that we should do multiplication first. And so what I'm going to do is divide both sides by PV. And now we can see that PV cancels out on this side, leaving us with FV over PV is equal to 1 plus r to the t, which stands for time. Okay, now the first thing to notice here is that our required rate of return is only going to be dependent on the ratio of these two things and t. And so this could either be 200 and 100 or 2,000 and 1,000, and the answer would be exactly the same because the ratio in both cases would just be 2. Now, here's where it gets a little sticky. We have to get rid of this exponent. But how do we get rid of exponents? Well, it turns out we can take both sides to the 1 over t power. And so when we do this, this exponent becomes t times 1 over t. And those things just cancel out and leaves it to the first power. And anything to the first power is just that thing. And so now we can simply subtract 1 from both sides. And I'm going to switch sides here so we can have our variable of interest on the left-hand side, as we like to do. Future value over present value And so our final equation is that the required return is equal to future value divided by present value to the 1 over t power minus 1. We have one more variable to solve for in this equation, and that is t. And we're actually going to go back one step from our previous board and use this equation. Future value over present value to the 1 over t is equal to 1 plus r. Now this is where it gets really difficult, because in order to get this t down out of the exponent, we have to do something kind of tricky. And that tricky thing is called natural log. And when I take the natural log, what happens is as follows. That ln means natural log. And when I do that, it brings that exponent down, and it becomes multiplied times the natural log of the base that that exponent used to be on. But of course, it's algebra, so I have to do the same thing to both sides. And so I've got the natural log of 1 plus r over here. Now, I've got t on the bottom here, and I would like it by itself. And so the first thing I'm going to do is multiply both sides times t, and then we'll go from there. Now we can cancel the t's on this side, and they just go away. And so all that is just 1 now. 1 times the natural log of future value divided by present value. One more step. I need to divide both sides by the natural log of 1 plus r. And when I do that, it's going to cancel out on this side, leaving us with just t. Now, will you need to do natural log in most of your finance classes? Probably not. But if you have to find this equation, now you know how to do it.